how to prepare science and technology. Majorly, India's achievements in science and technology are seen in various fields such as nuclear energy, space technology, defense, biotechnology, energy resources, computers and ICT, then digital India and nanotechnology. I am here to explain you how to prepare and what areas are very important and what are the key areas in preparing science and technology. Here in nuclear physics, what are the various concepts are very important. Here not only what areas are important and we have to know what areas are not important. Here we have nuclear physics. In order to deal with the nuclear physics, we have to know the basic concepts of nuclear physics and what are the concepts of nuclear physics, what are the various kinds of reactors established in India, in which areas they are established, and what are the fuels that are used in various reactors of India, and then what are the different kinds of research reactors that are established around India. These things are very important. Of course, isotopes are also comes under nuclear physics and their medicinal uses and purposes are also very important. Remaining other things you may not consider all those things. Only which areas we have to focus more is very important in grabbing Gurukula posts. Then whenever come to space technology, we have major achievements in space technology area. What are the different satellites that India is using currently now, and what are the different space vehicles, space satellite launching vehicles are used in India, their versions and variants, what are the propellants that are used in various launching vehicles, and what are the different satellites we are using now and what are the payloads that are arranged in each satellite is very important in this area. Of course, what are the research industries and research institutes are established in order to support the space technology in India are also very important. So, if you focus on these areas, we may able to understand the concepts of space technology as well as which areas are very important in understanding the space technology concept is, that's it. And if we deal with defense, what are the different kinds of missiles that are manufactured in India and who are involved highly in preparing the missiles, and what are the nature of those missiles, how to operate those missiles, these are also very important, and what are the institutions that are involved in manufacturing missiles are also very important. Then computers and digital India. As we know, India has major achievements in computer technology also. As a part of these computers, in order to serve the rural areas as well, the Indian government has established the digital India concepts by using digital technology. If we see energy resources, what are the major resources that are available in daily life and how we are using those energy resources, what are the nature of those energy resources and their availability, their classification, and what are the advantages of these energy resources and what are the drawbacks are also very important in case of energy resources. Of course, if we deal with biotechnology, we have few concepts of bioremediation, biofuels and stem cell technology, and then cloning and then in vitro fertilization concepts. These are also very important in case of biotechnology. In terms of robotics, we have gradually increasing our achievements in robotics technology. Of course, we have to know what are the different areas of using robotics in daily life and how they are helpful for us is very important. And if we consider to nanotechnology, this area may not be in vast. Of course, we have to know the key concepts of nanotechnology. So, let us see the topic of energy resources. Energy resources means the society from which it can obtain energy in order to obtain heat, light and locomotion is called energy resources. Of course, in nature we have two kinds of energy resources. First one is primary energy resource. This comes under solar energy, wind energy, tidal energy, etc. are comes under primary energy because they are available in nature. That's why they are called primary energy resources. The second thing is secondary energy resources. These comes from natural energy resources, hence they are called secondary energy resources. These are not available naturally in the nature, they are coming from the primary energy resources. Therefore, they are called secondary energy resources, such as fuels from fossils. Next, chemical fuels. Fossil fuels and chemical fuels comes under secondary energy resources, as these are not available in the nature naturally. That's why they are called secondary energy resources. Of course, based on the regeneration of energy resources, these resources can be reclassified into two areas, that is renewable energy resources and non-renewable energy resources. Renewable energy resources, the examples are again solar, wind, tidal energy, oceanic thermal energy and geothermal energy comes under renewable energy resources. Even if we use these resources gradually in our daily life, after certain time we can regenerate these energy resources, hence these are considered as renewable energy resources. Of course, these are not for the conventional use of societies, hence these are considered as non-conventional energy resources because they are not ready to use immediately after obtaining those resources. And non-renewable energy resources, by gradually utilizing these kind of resources, we can't regenerate these resources in the meantime or within short span of time, hence these are called as non-renewable resources. Of course, these resources are immediately usable, hence these are called conventional energy resources. Conventional energy resources. The various kinds of non-renewable energy resources available in the market are again fossil fuels and chemical fuels. By gradually utilizing these kinds of energy resources, we can't regenerate in the immediate or short span of time. Therefore, these are called as non-renewable resources as well as conventional energy resources. Of course, after certain time they are maybe exhaustible, hence they are called also exhaustible energy resources. Various names for these fossil fuels, chemical fuels are non-renewable energy resources as well as conventional energy resources as well as exhaustible energy resources. These are the alternate terminology to fossil fuels and chemical fuels. If we see non-renewable energy resources, fossil fuels and chemical fuels are comes under non-renewable energy resources. Various kinds of fossil fuels are coal, petroleum, natural gas and coal bed methane. These comes under non-renewable energy resources. And the chemical fuels such as uranium and shale gas, these comes under also non-renewable energy resources. In detail, coal. Coal is a black brownish sedimentary rock which is available in the underground layers of earth. Due to floods and other various reasons, trees were buried deeply into the deeper layers of earth. There exerts heavy pressure as well as temperature also. Under those heavy pressure and temperature circumstances, trees goes under anaerobic conditions. Due to these anaerobic conditions, the coal will be formed under the deeper layers of earth. So that's why these are called as fossil fuels. So coal is one form of non-renewable energy resource as well as fossil fuel. Depend upon the various percentages of volatiles available in coal, these can be classified into peat, lignite, bituminous, anthracite, graphite and coke. In detail, peat is one form of coal where 30 to 30%, 35% of carbon is available in peat coal. And come to lignite. In this lignite type of coal, 35% to 45% of carbon is available. If we see bituminous kind of coal, 50 to 80% of carbon is available. Of course, in anthracite type of coal, 90% of carbon is available, hence this is considered as the best mean of fuel. Of course, graphite is not a fuel. In this, it is used as manufacturing pencils, as well as when powdered it is used as lubricant in various industrial applications. Of course, coke has highest power of carbon, that is 95%. It is used as a reduction agent in industrial area. In order to understand the coal formation, the process of anaerobic condition is quite important here, as well as what are the different variants in coal available in the market is also important. Due to the percentages available in various types of coal, which comes to the best mean of fuel is important. Here, for example, coke is the best fuel available in the market. Of course, this has 95% of carbon in that. Along with coal, from coal mines we can obtain another energy resource called coal bed methane. Of course, this is also called as coal bed gas or coal seam gas or coal mines methane. Due to the presence of methane, it is also considered as a sweet gas. Of course, coal bed methane is obtained from coal mines in addition to coal. Next, petroleum is also called as a non-renewable resource of energy. This is obtained from Greek words, two Greek words, petra and oleum. Petra means rock and oleum means oil. So, these petroleum reserves are deeply available under the deeper layers of earth. Due to floods and other various kinds of reasons, plants and animals are buried deeply under the layers of earth. In that deeper layers of earth, due to the presence of high temperature and heavy pressure, and also due to the anaerobic conditions, the plants and animals are converted into petroleum. So, as well as coal also. So, coal like that, petroleum, these two are non-renewable energy resources, whereas petroleum obtained from the two Greek letters petra and oleum, which means petra means rock and oleum means oil. Of course, LPG, we have huge domestical as well as industrial usage. This comes under non-renewable energy resources, which is a mixture of propane and butane. We can see if any due to any leakages LPG in our daily usage, we experience one smell. That smell is comes. So, due to the mix of one component called ethyl mercaptan. Actually, LPG is an odorless gas. That means we can't experience any smell from LPG. In order to identify the leakages in our domestic usages, one component called ethyl mercaptan is mixed with LPG. Then only due to that smell of ethyl mercaptan, we can identify the leakages of LPG. Of course, natural gas is also comes under non-renewable energy resources. Of course, this constitutes of methane highly. So, previously we were asked whenever from the petroleum wells, which are comes first and comes later. If we see, natural gas comes first and then petroleum, then water. So, these are the components or products that we can obtain from petroleum wells. This was asked previously in one examination, what are the order of components that we obtain from petroleum well. The order is, firstly natural gas is obtained, then petroleum is obtained, later water is obtained from petroleum wells. So, after discussing about non-renewable energy resources, we must aware of which are non-renewable energy resources and which are renewable energy resource kinds. These are questioned in our examination. So, for example, coal is of which kind of energy resource? Of course, option may be given as non-renewable energy resource or renewable energy resource or alternate energy resource or exhaustible energy resource. Of course, like this we may face different kind of questions in our examinations. So, the next topic which we discuss here is renewable energy resources. So, in the meantime or in the short span of time, even though we are widely using these kind of resources, these are always available in the nature naturally. So, without any man-made efforts, these are available in the nature, hence these are called as renewable energy resources. Of course, these renewable energy resources replaces the conventional fuels or non-renewable energy resources, hence these are also considered as the alternate energy resources. Alternate energy resources. Why we are calling these alternate energy resources means by using these kind of renewable energy resources, we can replace the usage of conventional fuels. Basically in 4 areas we are using these kind of renewable energy resources, such as electricity generation and hot water usage or hot water production, of course motor fuels in the form of biofuels, natural gas, etc., and of course rural energy services. The main advantage of using these renewable energy resources is these are always available for the remote area societies, hence the government should support using the renewable energy resources widely in the remote areas, so that they can meet the demands of rural area societies in order to obtain their daily energy utilizations. Of course, what are the different kinds of renewable energy resources that are available in the nature are: first one is solar energy. Of course, the entire world is now running towards solar energy utilization processes by means of solar fields as well as solar heating equipments. These comes under renewable energy resources. The second kind of this kind of resources is wind energy, that is obtained from the wind. Of course, the kinetic energy of wind is converted into electricity or mechanical energy in order to meet our daily needs. Then oceanic thermal energy, due to the different temperatures in the oceanic waves, we use this oceanic thermal energy. Of course, this is not widely used in the nature. Next one is geothermal energy, due to the radioactive elements. Due to the radioactive elements that are present in the under deeper layers of earth, these exerts radiation as well as the rocks inside the earth will be heated up. So, due to that radiation, heat will be developed, and if we utilize that heat to various utilizations, those comes under geothermal energy utilizations. And then tidal energy is also comes under renewable energy resources, as this is always available in the oceans, hence this comes under renewable energy resource. We use tidal generator. We use tidal generator in order to produce electricity by using the tidal energy in the oceans. So, if we see how much energy is utilized by using renewable energy resources means 16% of energy currently utilizing by using these resources. Out of this 16%, 10% of energy is utilized by using biomass, whereas 3.4% of electricity energy needs or comes from hydroelectricity generation. Of course, 3% of energy consumption is from new renewable energy resources such as by using solar, wind energy and other means of energy resources. So, by using these terms, we must be aware of what are the renewable energy resources and what are not the renewable energy resources is quite important, and what are the solar techniques that are used in obtaining electricity by using solar technology is important, and which states are highly involved in producing solar energy is also important. We will discuss it now. As we are continuously utilizing the non-renewable energy resources such as fossil fuels or chemical fuels, the greenhouse gas emissions were emitted into the atmosphere, which causes pollution and greenhouse effect. Of course, by using the alternate to these non-renewable energy resources, renewable energy resources are mostly considered as eco-friendly energy resources, since they do not cause greenhouse gas emissions, hence they are widely used around the world. In case of solar energy, this is the energy obtained from electromagnetic radiation that is emitted by the sun. So, by using the radiation by the sun, we are using this in our daily life to meet our energy demands. So, in order to understand the solar energy concepts, we must understand about the solar constant. This is the concept which deals with the magnetic flux which is emitted by the radiation of the sun. That means this is the quantity of radiomagnetic energy that is obtained by the earth per square meter is nothing but solar constant. Of course, the exact value of solar constant is 1366 watts per meter square. In order to utilize the solar energy, we must use different technologies called photovoltaic technology as well as photo heaters, photo heating technology. So, in photovoltaic technology, solar cells are highly used. These solar cells are prepared by using silicon and boron layers. So, silicon boron layers were adjusted with a potential difference of 0.5 volts. These solar cells are widely connected to each other in order to form a solar panel. These solar panels are widely arranged in solar fields and we obtain by using this photovoltaic technology in order to obtain solar energy. Of course, around the world, 30 nations are obtaining their energy supply about 20% by using this solar energy technology. Of course, wind energy is also playing high priority because per year there is an increase in wind energy resource up to 30%. The another technology which is used to harnessing the solar energy is solar pond. In a normal pond, salt is added to the water. Due to the density changes in various layers, different layers are formed, different layers of water is formed in the pond. Of course, the radiation or the sunlight emitted by the sun is projected towards the water. Due to this radiation, the temperature of the water rises up to 85 degree centigrade. Due to the temperature differences in various layers of pond, we may utilize these steam into different energy utilizations. India is the first country in Asia that utilizes the solar pond technology. Of course, in Bhuj we have one solar pond in Gujarat. The natural solar pond that is in Sinai Island, which is in Egypt. We have 9.01 gigawatts of solar energy installations up to now in India. During 2015, 30,256 solar pumps, water pumps were installed in agriculture and remote areas of villages. Of course, 1 million of solar lanterns were sold in rural areas. Of course, 1,18,700 solar home-based lightnings were installed, and 46,655 solar street lights were installed, and 1.4 millions of solar cookers were installed in order to meet the rural area needs by using solar energy technologies. So, the main concepts which are used in solar energy harnessing is quite important here. The question area is what is the solar pond technology, and how the basic needs we are fulfilling by using solar energy is also important. In Indian point of view, Shivagangai solar project, which is installed in Tamil Nadu, is the first solar energy project. This is installed in 16th May 2011 with a capacity of 5 megawatts. If we comes to see the calculations of solar energy capacities in various years, in 2005 we have only 6.4 megawatts of solar electricity which is added to the grid. Whenever coming to 2010, we have 25.1 megawatts of solar electricity. In 2011, we have 468.3 megawatts of solar electricity is added to the grid. Of course, in recent years, we have up to 3000 megawatts of solar electricity is added to grid in order to meet the huge demand on energy resources. Of course, Tamil Nadu is the largest leader in producing solar electricity with a capacity of 2000 megawatts till now. Gujarat becoming a leader in harnessing solar electricity power generation, whereas Ultra Mega Green Solar Power Plant, this has been established near Sambhar Lake in Rajasthan. After completion of this is actually under construction now. After completion of this power plant with a capacity of 4000 megawatts, it will be the largest solar energy plant in the world, which is installed in near Sambhar Lake in Rajasthan. And if we see Bangalore, Bangalore has largest deployment of rooftop solar water heaters. It is the largest deployment of this kind of technology. Approximately this energy meets to 200 megawatts. In order to harness the solar energy in India, Indian government promotes Jawaharlal Nehru National Solar Mission, especially for harnessing solar energy. So, these are the key concepts in harnessing solar energy and the achievements of India in harnessing solar energy technology in order to meet the huge demands instead of using non-renewable energy resources. In order to harness the solar energy in the nations between Tropic of Cancer and Tropic of Capricorn, their initiatives International Solar Alliance in January 2016 by the efforts of India. Its headquarter is in Gurgaon. Of course, International Solar Alliance is mainly focused on promoting and developing solar energy as well as solar products in the nations between Tropic of Cancer and Tropic of Capricorn. Of course, we have Sri Sai Baba Samsthan in Shirdi. It has world's largest solar steam system which is able to cook food for 50,000 meals per day for its pilgrims. The same kind of mechanism has been seen in Tirumala Tirupati Devasthanam also. They are using solar energy systems for preparing food for their pilgrims. In case of wind power, the kinetic property of wind energy is converted into electric energy as well as mechanical energy in order to meet the huge demands of energy resources. Approximately in India, we have 27,676 megawatts of installed capacity of wind power generation. Of course, India is now fourth country behind China, USA and Germany with highest installed power of wind energy. So, by using these kind of mechanisms, greenhouse gas emissions were controlled in order to give peaceful and clean environment to the future generations, of course, so as to fulfill our needs based on these energy levels. And another form of renewable energy resources is biofuel. Biofuel includes bioethanol, biodiesel and biogas. Of course, these are obtained from the biodegradable waste which comes from agricultural industries, commercial industries, whereas industrial sectors. So, by obtaining these biodegradable waste coming from various sectors, these wastes should be undergone to an anaerobic digestion process which leads to the preparation of biofuels such that bioethanol, biodiesel and biogas. In rural areas, biogas is widely using as their gas and domestic heating purposes. Of course, by using these three kinds of biofuels, 60% of emissions were reduced in order to make the pollution eco-friendly. And another concept is gasohol. This gasohol is nothing but the mixture of bioethanol and gasoline or petrol. Various forms of gasohols are available in the world like E5, E10, E15. E10 and E15 are available in USA, whereas E5 type of gasohol is available in Europe, E25 and E85 and then E100. This key concepts refers to the percentages of ethanol as well as petrol. E5 refers to 5% of ethanol plus 95% of petrol. That means 5% of ethanol is blended with the 95% of gasoline or petrol, which forms the E5 type of gasohol, whereas E10 means 10% of ethanol blended with 90% of gasoline or petrol so as to form E10 kind of gasohol. Like that, E85 in the sense 85% of ethanol is blended with 15% of petrol. So, in order to mix these kind of gasohol percentages, the emissions gradually reduced in the atmosphere so as to give the eco-friendly environment to the future generations. Basically, these kind of energy resources terminologies will help you to get awareness about the nature so as not to emit the greenhouse gas emissions into the environment in order to get eco-friendly environment for the future generations. So, up to now we are examined renewable and non-renewable energy resources which are mostly useful now and which are to be useful and to be used in the future. So, to meet our basic energy demands and which are helpful, which are harmful also discussed here. By discussing all these things as an aspirant, it may be useful to you to grab the Gurukula post as well as in order to getting the awareness of this environment and energy resources, that is also helpful to you a lot. Now, we will discuss about nuclear physics as a part of science and technology. This nuclear physics has been developed after the invention of radioactivity property by Henry Becquerel in 1869. Later, these inventions were carried out by Pierre Curie and Marie Curie. After that, Ernest Rutherford. The substances which shows the radioactive property are called radioactive substances. The property of radioactivity is depend upon the number of nucleons in an atom. If the atom having a less number of nucleons, that atom is considered as a stable atom, whereas if it contains heavy number of nucleons, then it becomes very unstable. In order to become unstable atom into stable atom, it expresses the property of radioactivity by emitting various particles as well as energy in the form of alpha, beta and gamma. Whereas alpha and beta are particles, whenever it emits the gamma rays, then the energy of the atom will be reduced in order to get stability. Of course, by emitting alpha particle, here is the equation, and if we consider the terminology uranium 92 and 238, here 92 is referred to as atomic number, whereas 238 is referred to as mass number. Of course, alpha particles are considered as helium nucleus with atomic number 2 and mass number 4. By emitting alpha particle from the uranium atom, it will become thorium 90 and 234. As we see here, the atomic number is reduced by 2 units, whereas the mass number is reduced by 4 number. And if we see the radioactive decay properties, we have two kinds of radioactive decay processes, such as natural radioactive decay, whereas artificial or induced radioactive decay processes. Elements like uranium and thorium, these exerts alpha and beta particles as well as gamma rays naturally in the nature, so that the radioactivity exerted by the elements uranium and thorium are considered as natural radioactivity. Whereas whenever a light element is bombarded with particles like alpha, beta, gamma or protons and neutrons, they will become to exert the radioactive property. Hence, that kind of radioactive property is known as artificial or induced radioactive property. This property is identified and developed by Irene Curie and Frederick Joliot. These two were later awarded with the Nobel Prize for their invention. What is the main reason behind the nuclear physics is quite important here, and what are the properties that are exerted by the radioactive substances in order to become stable is more important, and what are the reaction processes that are involved in radioactive property is to be understood in order to get good score. So, if we express the radioactive property in terms of units, the measurements are Becquerel, Rutherford and Curie. These are the units of measuring radioactive property. And we have various devices which are used to identify the radioactivity, such as bubble chamber, Geiger counter, scintillation counter and solid state counter. These four devices are used to identify the radioactive property. Whether the element or atom exerts the radioactivity property or not are measured by these four devices. Later, atomic energy is the energy that is exerted by the atom. This is originated by Ernest Rutherford in 1903. Later, this term is most popularized by H.G. Wells, which he gives a meaning that splitting the atoms. This concept was most popularized by H.G. Wells. And we have few kinds of nuclear reactions which are related to radioactive property as well as nuclear physics. Those are nuclear fusion and nuclear fission. Nuclear fusion means lighter elements joined together to form a heaviest particle or heaviest element is known as nuclear fusion. Nuclear fusion in the sense lighter elements joined together in order to make a heavier particle. For this kind of nuclear fusion reactions, there must be higher temperature and highest pressure is needed, so that these reactions are naturally formed in stars such as sun and other kind of stars. Of course, nuclear fusion is the reason behind the radiation that are emitted by the stars and other substances. Of course, this is the major reason behind hydrogen bomb also. In order to explode the hydrogen bomb, in order to obtain the fusion circumstances, we must explode another bomb called nuclear bomb that will be discussed later. Whenever we come to nuclear fission process, this comes under heaviest particles split into lighter particles. The process of heaviest particles split into lighter particles so as to make other elements is known as nuclear fission. The reason behind uranium bomb or this is also called as nuclear bomb, and nuclear fission is also the reason behind nuclear power stations. Where nuclear reactors are widely used in order to obtain the atomic energy so as to produce the electricity in nuclear power station. The main reason behind these two concepts, uranium bomb and nuclear power station, is nuclear fission, whereas the reason behind hydrogen bomb is nuclear fusion. These concepts are very, very important in order to identify the characteristics of nuclear physics, and by using this nuclear fission reaction, nuclear reactors are constructed so as to generate the power in order to meet the natural energy demands. The concept of nuclear fission is invented by Otto Hahn and Strassmann. Of course, in the nuclear fission process, more neutrons were ejected from the particles. If more fissionable elements or particles are available, this leads to another nuclear fission process. If the process is continued in the same manner, this is considered as the chain reaction. Here we have a special apparatus or equipment called a nuclear reactor or atomic pile, in which we can control the chain reaction of nuclear fission process so as to use this energy released by the nuclear fission process to generate electricity power in nuclear power stations. Of course, if we see the nuclear reactor components, we have several components here. The first one is fuel. Of course, the fissionable elements such as plutonium and thorium are considered as the nuclear fuels which are used in nuclear reactors, whereas nuclear reactor core, it contains the nuclear fuel components along with it, hence it is called nuclear reactor core. And then nuclear moderators were used. These are used to control the speed of neutrons, hence these are called neutron moderators. Normal water, heavy water, graphite and beryllium are acts as neutron moderators, which are used to minimize the speed or control the speed of ejected neutrons in the fissionable process. And here we have neutron poisons. In some crucial or typical situations which leads uncontrolled chain reaction process, we use these neutron poisons in order to absorb the extra neutrons in order to control the chain reaction or stop the chain reaction. For example, xenon 135 acts as a neutron poison. These are introduced whenever the chain reaction, controlled chain reaction becomes uncontrolled chain reaction. In that situations only we apply neutron poisons in the neutron reactors. And coolant is another component of nuclear reactor. This is used to minimize the temperature, huge temperature that is raised due to the nuclear fission process in the nuclear reactor. so that the temperature of the nuclear reactor will be minimized and the heat energy or heat temperature is supplied to other devices in order to generate the electricity in the power stations. The various coolants are available such that normal water or light water and heavy water, liquid metals such as liquid sodium and liquid nitrogen, these are all worked as coolants. We have another component called control rods. These are used to control the fission rate in the nuclear reactor. We use boron and silver as control rods. Of course, Chicago pile is the world's first nuclear reactor, which is invented by Enrico Fermi in the year of 1942. This is the main question area in our examinations, like that which of the following is a neutron poison or which of the following is not a neutron poison. Otherwise, you may ask which of the following is a moderator or which of the following is not a moderator. In these areas, we may give questions in our examinations. So, as by thoroughly understanding these concepts, we will able to answer each and every this type of question in our examination. We have various types of nuclear reactors around the world. If we see the classification of reactors, the classification of reactors is based on two types. One is moderator and another one is based on coolant used in the nuclear reactors. Based on various moderators used in nuclear reactors, these are categorized as graphite moderated reactors, graphite moderator reactors, as well as water moderator reactors, and then heavy water moderated reactors, then light water moderated reactors. Another kind of reactor is molten salt reactor, liquid metal cooled reactors. Here actually the term cooled indicates that this comes under coolant type reactors, but here we use beryllium oxide as moderator, hence these also comes under this section. That means nuclear reactors can be classified based on the moderator that are used in the reactor as these follows: graphite, water, heavy water, light water, molten salt and liquid metal cooled reactors. As moderators are used to control the speed of neutrons that are ejected from the fissionable elements in the chain reaction process. If we see the various kinds of reactors based on coolants used in the nuclear reactors are water cooled reactors, pressurized water reactors and pool type reactors, liquid metal cooled reactors. Under this liquid metal cooled reactors, we use liquid nitrogen, liquid sodium. These kind of reactors are available in the world. Whereas we have another kind gas cooled reactors. These are the classification of reactors based on moderators and coolants. Of course, we see water is heavily used in these reactors as coolant as well as moderator. The basic reason behind water is used as coolant in the nuclear reactor is that water has a more specific heat capacity. That means we have to supply more heat energy in order to increase its temperature to 1 degree centigrade. That means water utilizes more heat energy in order to increase its temperature to 1 degree centigrade. Hence, water is used widely as a coolant in most of the worldwide nuclear reactors. So, these are the various reactors which are used around world. Of course, amongst these, pressurized water reactors and pressurized heavy water reactors are also heavily used in India also. Most of the reactors which were installed in India belongs to pressurized heavy water reactors. Of course, we have another kind of reactor also, that is boiled water reactor. If we see pool type reactor means the nuclear fuel, whereas nuclear core are all merged in water. So here water acts as moderator as well as coolant, as well as it is used to reduce the pressure exerted in the reactor. These are the pool type reactors where the nuclear fuel and nuclear core merged in water, where water is acted as a moderator, coolant, and it is also used to reduce the pressure inside the nuclear reactor. If we see nuclear power scenario in India, nuclear power is the fourth largest source of electricity in India after thermal electricity, hydroelectricity, and renewable source of electricity. That means we have fourth largest priority given to nuclear power in India. In India, 21 reactors were installed in 7 plants, of which having installing capacity 6,780 megawatts. Cumulative energy total is 30,292.91 gigawatts. And in addition to these 21 reactors, we have 6 more reactors to be constructed with a capacity of 4,300 megawatts in future. The first research reactor in India is Apsara. With the assistance of UK, it is installed on August 4th, 1956. The second research reactor is Cirrus. With the assistance of Canada, it is installed in India. Rawatbhata Atomic Power Plant 1. Plant 1 is the first power plant in India established in the year of 1963. Later, RAPP2 or Rawatbhata Atomic Power Plant 2 were installed as the second power plant. Up to now, Russia is the main source to import uranium fuel, of which it is already assisted the importance and implementation of nuclear power in India. In September 2008, India made nuclear fuel agreements with nuclear supplying groups with the countries such as France, UK, USA, Canada, South Korea. Along with these countries, India has bilateral agreements with Russia, Mongolia, Kazakhstan, Argentina, and Namibia. By providing nuclear supplying agreements with these countries, sufficient amount of nuclear fuel in the form of uranium will be imported to India so as to reach the power utilizations and power demand in India is possible. In Rajasthan, Rawatbhata Atomic Power Plant, first plant is installed based on CANDU reactor in Douglas. If we see the number of atomic power plants which are installed in our state, in our country, India is, in Maharashtra we have Tarapur Atomic Power Plant with 4 plants. Out of 4 plants we have 2 boiled water reactors and another 2 pressurized heavy water reactors. Both of these 2 reactors are having the capacity of 1400 megawatts of electric power. Rajasthan, we have Rawatbhata Atomic Power Plant with 6 plants. Out of 6, all of belongs to pressurized heavy water reactors with a capacity of 1180 megawatts. In Tamil Nadu, Kudankulam power station is there. In this 2 power plants are there, of which VVER or water enabled reactors. This is the most advanced technology in nuclear reactors. Of capacity 2000 megawatts were installed in Tamil Nadu. Whereas in Karnataka, we have Kaiga power plant with 4 plants. Out of these 4, all belongs to pressurized heavy water reactors with a capacity of 880 megawatts. In Gujarat, Kakrapara power plant is there with 2 power plants. Out of these 2, all belongs to pressurized heavy water reactors with a capacity 440 megawatts. In Tamil Nadu, Kalpakam power plant is there with 2 power plants, 2 nuclear power plants with pressurized heavy water reactor type with a capacity of 440 megawatts. In Uttar Pradesh, Narora power plant with 2 plants of pressurized heavy water reactor type with a capacity 440 megawatts. These are all already installed with the total capacity of 6,780 megawatts. And 6 more nuclear power plants were under construction, in which Rajasthan has 2 power plants with pressurized heavy water reactor type with a capacity of 1,400 megawatts. In Gujarat, another 2 power plants were under construction with pressurized heavy water reactor type of capacity 1,400 megawatts. In Tamil Nadu, one prototype fast breeder reactor. Here, fast breeder reactor in the sense these reactors can produce their fuel on their own. Hence, these are called fast breeder reactors. Of course, these comes under prototype fast breeder reactor with a capacity of 500 megawatts. And in the same state, Tamil Nadu, we have another plant with VVER, that means water enabled reactor of capacity 1000. Of these 6 new power plants which are under construction are having 4,300 megawatts of electric power. After constructing all these reactors, another amount of 4,300 megawatts of capacity will be added to previously having capacity 6,780 megawatts, which will be the largest sector of energy resource in producing electricity in India. This is the another key area where we can expect examination point of view bits in this regard. In which state Kaiga is installed, or in which state Kaiga is belong to, maybe this kind of questions expected. Of course, what is the total installed capacity of nuclear power plants in India? This type of questions may be expected. In which state the newly constructed power plants are enabled, or in which states they are not enabled, like that this type of questions also expected from these 2 areas. Few research reactors were installed in India for performing various research activities related to nuclear energy. These research reactors were operational under Baba Atomic Research Center, Trombay, and Indira Gandhi Center for Atomic Research, Kalpakam, which is located in Tamil Nadu. The research reactors which are operational under BARC are, these are the research reactors. Gerlina, this is of capacity 100 watts with natural uranium based reactor, in which heavy water is used as the moderator as well as coolant. Another research reactor that is installed in BARC or Baba Atomic Research Center is Apsara. This is of having capacity 1 megawatt. It is the Asia's and India's first reactor which is of pool type or swimming pool type with uranium based reactor. That means here the fuel used in this reactor is uranium, and light water is used as moderator. Another research reactor is Cirrus of 40 megawatt capacity. This is the second reactor with assistance of Canada. It was installed at BARC Center. In this, heavy water is used as a moderator, whereas the fuel is uranium. Another reactor is Dhruva with a capacity of 100 megawatts. In this, heavy water is used as a moderator as well as uranium as fuel. This is the India's largest research reactor. This specialty gives you the key area for having a question here. Hence, we must notice this carefully. Dhruva is the India's largest research reactor. Of course, you may ask, which of the following is the largest research reactor? In that situation, we have to answer Dhruva as the answer. Another 3 kinds of reactors are there under Purnima series: Purnima 1, Purnima 2 and Purnima 3. Purnima 1 is a plutonium based reactor, whereas Purnima 2 and Purnima 3 are uranium based reactors with light water as moderator as well as coolant, where Purnima 2 is having a capacity of 100 megawatts as well as Purnima 3 is having a capacity of 1 watt. The various research reactors that were established at Indira Gandhi Center for Atomic Research, Tamil Nadu are PFBR, FBTR and Kamini. These are of fast breeder type reactors. That means these reactors can produce their own fuel on their own. The reactors which produces their fuel on their own are known as fast breeder reactors. Here we have prototype fast breeder reactor of capacity 500 megawatts having liquid sodium as coolant. Another reactor is a fast breeder test reactor with a capacity of 40 megawatts. This is having fuel with the mixed fuels, that means uranium plus plutonium. This is by this India becomes the 7th nation to have breeder type reactors. With the successful installation of FBTR at IGCAR Tamil Nadu, India becomes the 7th nation in the world to have a breeder reactor. Another reactor is Kamini reactor with a capacity of 30 kilowatts. This is the joint venture by BARC and IGCAR. This reactor is having thorium as the fuel, and by this we can utilize the heavy thorium reserves which were there in Kerala beach areas. And we have another key concepts where we can expect the question is isotopes. Isotopes are the elements with same atomic number but different mass numbers. These isotopes are widely used in medicinal usage in order to cure cancer as well as iodine deficiencies. Of course, isotopes are of type 1H1, 1H2 and 1H3 are the isotopes of hydrogen, where 1H1 is called as protium, this one is 1H2 is called as deuterium and 1H3 is called as tritium. In case if we see the isotopes of carbon, C612, C613 and C614 are the various isotopes of carbon. Here the atomic number is same, whereas mass numbers are differ from each other. Of course, heavy water is used as moderator in our nuclear reactors. In order to make India as the largest manufacturer of heavy water in the world, we have established few heavy water organizations in Gujarat, at Baroda and Hazira. Heavy water plants Baroda and Hazira are located in the state Gujarat, whereas heavy water plant Kota is located in Rajasthan, and heavy water plant Manuguru is located in Telangana, whereas heavy water plant Talcheru is located in Odisha, and heavy water plant Tuticorin is located in Tamil Nadu. This is the key area to having a question in our examinations, such that Kota heavy water plant is located in which state, or which of the following is the fast breeder type reactor established under IGCAR. This type of questions may be expected in our examination. So, we must be thoroughly having awareness of these kinds of key points will help you in scoring the examination.